Okay, this video is now, I believe, the 9th in the series that I'm doing about fractions. So the previous video, we talked about adding fractions and mixed numbers where they had the same denominator. So for this video, we're going to talk about subtracting fractions where we have the same denominator, fractions and mixed numbers. After this video, I'm going to do 2 videos, one on adding fractions and mixed numbers with different denominators. Then I'll do subtracting fractions and mixed numbers with different denominators. And then we'll wrap up the series by doing order of operations. So the series on fractions just about done. Okay. Okay, so subtracting fractions and mixed numbers. And remember, we're still dealing with what we call common denominators. That means the denominators are the same. Now, the good news about this particular video is it's going to be almost identical to the video on adding fractions with common denominators. The only difference is that instead of adding the numerators, we subtract the numerators. So if I had A over B minus C over B, make note that we do have common denominators. So I would take my numerators, I would subtract them, and I would keep the common denominator. So as long as you have common denominators, you subtract the numerators. We keep the common denominator. And this is something I focused on in the last video, and I'll focus on it again. We simplify last. All right. So I'm going to underline last, put it in all caps, add a couple exclamation points, and then just to make sure we really hit home, I'm going to put that dramatic red star again. Okay. So as long as you have common denominators, you subtract your numerators, keep the denominator, simplify at the end. If you simplify your fractions to begin with, you're going to put them in a state where they no longer have common denominators, and that's just really counterproductive. So simplify at the very, very end. Okay, let's look at some examples. For the first example, I have 15/18 minus 12/18. Both of these fractions are not reduced, okay? But we don't want to go and take the steps to reduce them, okay? If we were to reduce these fractions, we would get, let's see, 5/6 minus 2/3. We no longer have common denominators, which is a problem, okay? So we want to just leave things well enough alone, keep the common denominator, and subtract those numerators. 15 minus 12 is 3. Keep the common denominator of 18. And then I noticed that 3 and 18 have a common factor of 3. I'm going to divide both of these numbers by 3. 3 divided by itself is 1. 18 divided by 3 is 6. And my final answer is 1/6. All right, so you can see this is almost identical to the previous video where we're adding. The only difference is what we do with the numerators. All right, what if I had 21/15 minus 8/15? All right, you want to make sure that you have common denominators. We do. We've got the common denominator of 15. I subtract my numerators. 21 minus 8 is 13. My common denominator is 15. 13 and 15 have no common factors, so I'm done. Let's try a few more like this. What if I had 7/24 minus 3/24? All right. So 7/24 minus 3/24, we have a common denominator of 24. I subtract my numerators. 7 minus 4 is 3. I get 4/24. I notice that 4 and 24 have a common factor of 2, but they also have a common factor of 4. So let's divide 4 out. 4 divided by itself is 1. 24 divided by 4 is 6. And again, just like the first example, my final answer is 1/6. All right. I've noticed I say all right a lot when I do these videos. So next example, we have 99 over 100 minus 63 over 100. Keep in mind that you don't have to be flipped out by doing side work. I think a lot of people get a little nervous about doing side work because they're like, oh, I'm too stupid to do it in my head. Don't sweat it. Sometimes I do side work and I'm doing math quite literally for a living. So we've got a common denominator of 100. And let's say you look at 99 and 63 and you're not really sure what the answer should be. Do some side work. 99 minus 63. 9 minus 3 is 6. 9 minus 6 is 3. So my numerator is 36. Okay. Don't forget to do your side work. Okay. Don't always rely on your calculator. Sometimes it's nice to do that arithmetic on paper just to kind of keep it fresh. Now, we want to reduce 36 over 100. So they're both even. Okay. And let's say that we see that they're both even. So they're divisible by 2. So 36 divided by 2 is 18. 100 divided by 2 is 50. So I simplify a little bit to 18/50ths, but am I done? Well, no, I'm not done because 18 and 50 are still even. That means they're divisible by 2. So 18 divided by 2 is 9. 50 divided by 2 is 25. And now you can see 9 and 25 have no common factors. So our final answer is 9/25. Now, it's always nice if you can find the greatest common factor when you're simplifying, but sometimes it's not always going to happen. So just keep simplifying. Like right here, it took us 2 steps to simplify. No big deal. We got it done. All right, let's try 2 more of these, and then we're going to start talking mixed numbers, okay? And with mixed numbers, there's kind of an extra step, so we'll do lots and lots of examples of mixed numbers. All right, so we'll do 2 more with just fractions. So for this example, I have 24/75 minus 9/75. I've got common denominators, so I know my answer to start is going to be something out of 75. Well, 24 minus 9 is 15. Okay. And I noticed that 15 and 75 are both divisible by at least 5. They both end in a 5. So let's go ahead and see what happens when I divide by 5. Well, 15 divided by 5 is 3. 75 divided by 5 is 15. And keep in mind, you can do some side work. If you weren't sure what 75 divided by 5 was, go over here to the side and do it. 5 will go into 7 once. 1 times 5 is 5. Subtract and I get 2. Drop down the next digit in line, which is a 5. Repeat the process. 5 into 25 is 5. 5 times 25 is, or 5 times 5 is 25. 0 remainder. So see, this is where that 15 comes from. Okay. So at this point, I have the fraction 3/15. Is this reduced? Well, no. 3 and 15 have a 3 in common. So 3 divided by 3 is 1. 15 divided by 3 is 5. And that is your final answer. All right. So a couple of things I want to reiterate in this video. Do the side work. Don't be ashamed of the side work. Don't force yourself to try to do everything in your head. And you do not have to simplify in one step. In the last 2 examples, it took us a couple of steps to simplify, and that is fine. All right. One more example with just fractions. For this example, I have 27 over 38. I want to subtract 9 over 38. Okay. I have a common denominator of 38, so I'm going to get something over 38. I subtract my numerators. So 27 minus 9, let's see, that would be 18. All right. I know they're both even, 18 and 38, so I'm going to divide by 2. 18 divided by 2 is 9. 38 divided by 2 is 19. Factors of 9 are 9 and 3. 9s do not divide into 19. 3s do not divide into 19. So my final answer is 9/19. And there you have it. So just a quick recap. Subtracting fractions is just like adding fractions. when you have a common denominator, you add or subtract the numerators. In this case, we were subtracting. You keep whatever the common denominator is, and then you wait until the very end to reduce. Okay. If you reduce before the very end, you're going to get yourself in a situation where you no longer have common denominators, and that is completely counterproductive. All right. So we did lots of examples. Now let's move on to mixed numbers. And again, we're still dealing with common denominators. Now, I'm going to remind you of something from a video that we did a few videos ago. Recall, with multiplying and dividing mixed numbers, you must convert to improper fractions first. All right. So everything with multiplying and dividing is completely different than everything with adding and subtracting as far as fractions or mixed numbers are concerned. So when you're multiplying and dividing mixed numbers, you must, absolutely must, convert them to improper fractions first. But one thing we noticed in the previous video, we did not have to do that with adding, and the same thing is going to be true for subtracting. Okay, so let's do a couple of stars here. You do not have to convert to improper fractions with addition or subtraction. You can if you want to, but you don't have to, okay? And for me, my personal preference is to actually keep them in mixed number format. I find converting them to improper fractions, it takes extra steps. And then what happens is when you convert to improper fractions, you get these really big numerators, and it can sometimes be difficult to subtract. It can be difficult to simplify. It can also be difficult to convert back to a mixed number, because I also prefer that if I start with mixed numbers, I end with a mixed number. So I think this idea of converting your addition and subtraction problems to improper fractions first, it just takes extra steps. Those extra steps just give you extra chances to make a mistake. So I keep my numbers in mixed number format. So for me, I keep the mixed number format. I subtract the fraction parts. Now, there can be situations where you have to borrow, borrowing when necessary. And borrowing here is going to be a little different than the borrowing that you might be used to with just like whole numbers when you subtract. But we keep the mixed number format, subtract the fraction parts, borrowing when necessary, subtract the whole number parts, and simplify as needed. All right, so I have quite a few examples. I have 4 problems where we're just going to have normal subtracting mixed numbers, no borrowing. I've got 4 examples where we take a whole number and we subtract a mixed number. And then finally, I'm going to have 4 examples where we subtract mixed numbers and borrowing definitely comes in. Okay, so let's start. So first up, I have 7 5/8. And you'll remember from my previous video that with mixed numbers, when I'm adding and subtracting, I do like to write them in vertical format. This is absolutely not required. It's just a preference of mine. So I've got 7 5/8. I want to subtract 3 1/8. Okay. Well, I've got common denominators in my fractions, so I can go ahead and subtract my numerators, and I can take 1 from 5. So 5 minus 1 is 4. That goes over 8. And then I want to subtract my whole numbers. 7 minus 3 is 4. Now, very last step you always want to look for is, do I simplify the fraction? In this case, yes. 4 and 8 have a common factor of 4. 4 divided by itself is 1. 8 divided by 4 is 2. My final answer is 4 and 1/2. Not bad. Okay. Next up, we have 24 and 11/33 minus 14 and 8/33. Okay. Check to make sure you have common denominators. We do. Our denominator is 33. You can then subtract your numerators, top numerator minus bottom numerator. So that's going to be 11 minus 8, which I can do. So I get 3 over 33. I then want to subtract my whole numbers. 4 minus 4 is 0. 2 minus 1 is 1. And then we simplify. 3 and 33 have a 3 in common. So 3 divided by itself is 1. 33 divided by 3 is 11. So my final answer is 10 and 1/11. Piece of cake, right? It's not too bad. Let's try another one. So let's say I have 31 and 9/12 minus 18 and 1/12. Okay. Make sure you have common denominators. We do. We have a 12. I can do the subtraction of 9 minus 1. I get 8 over 12. And then we're going to borrow here, but we're not doing the weird fraction borrow. We're just doing regular whole number borrowing. So I cannot take this 8 and 18 from the 1 and 31. So I borrow from the 3. It becomes a 2. The 1 becomes an 11. 11 minus 8 is 3. 2 minus 1 is 1. So at this point, I have 13 and 8/12. Can I simplify the 8/12? Yes. 8 and 12 have a 4 in common. 8 divided by 4 is 2. 12 divided by 4 is 3. And finally, I get 13 and 2/3. All right. One more like this, and then we'll go to learn how to do that borrowing. Okay. And we'll start easy with just a whole number minus a mixed number. So last easy example, we have 29 and 8/15. From that, I want to subtract 13 and 2/15. I have a common denominator of 15, and I can subtract 2 from 8. So 8 minus 2 is 6. I get 6 over 15. And then I want to subtract my whole numbers. 9 minus 3 is 6. 2 minus 1 is 1. So I get 16 and 6/15. I do need to address the 6/15. It needs to be reduced. So 6 and 15 have a 3 in common. 6 divided by 3 is 2. 15 divided by 3 is 5. So our final answer is 16 and 2/5. All right. So these 4 examples were pretty straightforward. We had common denominators, and we could do the subtraction. We could take away the second numerator from the first numerator. Okay. The next examples I want to show you are where you have a whole number minus a mixed number. And I'm going to show you how to borrow with these examples because I think it's a little easier. And then we'll dive into the kind of more complicated examples. All right. So let's say for our first example that we have 36 minus 6 and 2/5. Okay. Well, I have nothing to take my 2/5 away from. I have to have something to subtract, okay? So what I want to do is I want to rewrite 36 so that it's a mixed number. So how in the world do you convert a whole number into a mixed number? Well, here's what we do. We borrow 1 from 36, turning 36 into a 35, okay? And then what I do with that 1 that I borrowed, I write it in fraction form using the denominator that is already in the problem. I want to make sure I maintain common denominators. So I want my denominator in this fraction to be a 5 in this case. The fraction has to have a value of 1, so I can just write it as 5 over 5. And over here, keep in mind, what is 35 plus 5/5? Well, this equals 1. So this is really 35 plus 1, or 36, right? So we haven't changed the value of 36, but we have very much changed the appearance of 36, okay? So let's clean this up a little bit. I have 35 and 5/5. I want to subtract 6 and 2/5. Well, I can take 2/5 from 5/5. All right, 5 minus 2 is 3. So I'm going to get 3 over 5. And then for the whole numbers, we just do regular subtraction. Okay, so I can't take 6 from 5. I take 1 from the 3. The 5 becomes a 15. So 15 minus 6 is 9. And then there's nothing to subtract from the 2. So I just drop down the 2. And this right here is your final answer. Okay, so these problems right here where you do have to do the borrowing, they can get a little messy, but I would not say they're necessarily difficult. Okay, let's try another one. Whoops. Okay, 18. And we're going to go 18 minus 12 and 5/9. So just like the previous example, I have this whole number 18 and I want to subtract 2 and 5/9, but there's nothing to subtract 5/9 from. So I want to rewrite 18. I want 18 to be a mixed number. So the way I do that is I borrow 1 from the 18, I make it a 17. So I get 17. And then that 1 that I borrow, I'm going to add it back in here as a fraction. And I need that fraction to have a 9 as the denominator. So I'm going to write that fraction as 9/9. What is 17 plus 9/9? Well, it's 17 plus 1, or 18. All right, so again, we haven't changed the value of 18, but we have very, very much changed the appearance. So now from 17 and 9/9, or really 18, we can subtract 12 and 5/9. So let's see, 9/9 minus 5/9 would be 4/9. 17 minus 12 would be 5. And that's it. That's it. That's literally all you have to do. So that's how you borrow. Whoops. That's how you borrow when you're dealing with mixed numbers. All right. Let's try another one. How about 20 minus 13 and 4/15? Okay. So again, I want to convert 20 into a mixed number. All right. So I'm going to borrow 1 from the 20, making it a 19. That 1 that I borrow, I'm going to write it back in here as a fraction with 15 as the denominator. Well, 15 over 15 equals 1, and it has the denominator that we're looking for. All right. So now I can take 4/15 from 15/15. 15 minus 4 is 11. So I get 11/15. And then 19 minus 13 is 6. And that's it. All right. Piece of cake. Let's do one more just to make sure we got it. What about 100 minus 41 and 8/21? So just like the previous examples, we want to rewrite 100 so that it's a mixed number. So I'm going to take 1 away from the 100. That's going to make it a 99. The 1 that I borrow needs to have a denominator of 21. So now 100 is really, in this case, going to be 99 and 21 over 21, still equals 100, just looks really different. From that, I'm going to subtract 41 and 8 over 21. So now I can take 8 over 21 away from 21 over 21. So 21 minus 8 is 13. So I get 13 over 21. And now I want to subtract the whole numbers. So 9 minus 1 is 8. 9 minus 4 is 5. And that's it. All right. So these 4 examples are a little easier than the next 4 that we're going to do, but it shows you kind of the process of how you take that whole number and you borrow. Okay. So the next 4 examples I'm going to take my time with. All right. We're going to start with 15 and 1/12. minus 6 and 7/12. So I have two full mixed numbers. Okay, I have common denominators, but the issue here is with the numerators. I cannot take 7 from 1. All right, 1 is less than 7. This causes a problem. So what do? I borrow. Okay, so the 15, I'm going to borrow 1 from it, and it's going to make it a 14. That 1 that I borrowed, I'm going to add in as 12/12. Let me clean that up a little bit. So instead of 15, we're going to get 14. And then we have that original 1/12 plus the one that I borrowed from 15, which is 12/12. Okay. So that's going to become 14 and 13/12. Okay. Now, I'm sure some of you are like, whoa, 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 whoa. You can't have an improper fraction in a mixed number. And that is true. This is the one exception where it's okay because it's not going to stay improper for very long. This just allows us to subtract. So now I want to go ahead and subtract 6 and 7/12. Okay. So 13/12, I can now subtract 7/12 from. 13 minus 7 is 6. And then 14 minus 6 is 8. And last thing I want to do is just make sure my fraction is simplified. 6 and 12 are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So the final answer here is 8 1/2. Okay, let's do more, because again, the problem with these is that they get a little messy. It's not necessarily difficult, it's just it's easy to get unorganized. Okay, so next up I have 9 7/18 minus 6 and 11/18. So this is just like the previous example. I've got common denominators. However, the first numerator is less than the second numerator. I cannot take 11 from 7. No big deal. We borrow. So the 1 is going to be borrowed from 9. That's going to make my 9 and 8. And the one that I borrow, I'm going to add in to this fraction as an 18/18. Okay, let's clean up. So I'm going to clean up in just one step here. So my whole number is now 8. And then I'm going to take this 7/8 and I'm going to add that 1 that I borrowed. Okay, so 7 plus 18 is 25. My denominator is 18. And again, this is the only time it's okay to have an improper fraction in a mixed number. And it's only going to be like this for a second. Once I subtract 6 and 11/18, everything falls into place. Okay, so 25/18, I can now subtract 11/18 from. 25 minus 11 is 14. So I get 14/18. 8 minus 6 is 2. And all I have left to do is simplify my 14 and my 18. 14 and 18 are divisible by 2. 14 divided by 2 is 7. 18 divided by 2 is 9. And our final answer is 2 7/9. That's it. So it's a little messy when you do the borrowing, but it's not really that difficult. Let's try 2 more. So 26 and 2/9. From that, let's see if we can subtract 10 and 5/9. Okay. So same as the last 2 examples, we have common denominators, but the problem is the second numerator is bigger than the first numerator. I cannot take 5 from 2. No big deal. I'm going to borrow 1 from my 26. I'm going to make it a 25. The 1 that I borrow, I'm going to add back in over here to the 2/9. So I'm going to write it as 9/9. Okay, 9/9 is equal to 1. All right, and it has that denominator that we need. So let's clean it up. So I get 25. And now I'm going to add 2/9 and 9/9. So 2/9 and 9/9 is 11/9. Don't sweat the fact that it's improper. It's going to be improper for just a moment. So from 25 and 11/9, I'm going to subtract 10 and 5/9. So 11 minus 5 is 6. So I get 6/9. 25 minus 10 is 15. And all I have left to do is reduce the 6/9. 6 and 9 have a 3 in common. 6 divided by 3 is 2. 9 divided by 3 is 3. So our final answer is 15 2/3. That's it. One more example, and I think I did this problem a little too big, so I'm going to go to the next slide. Okay, so let's say I have 51 and 3/21. Do not reduce. Okay, remember, don't reduce until the end. I want to subtract 25 and 8/21. So same as the previous examples. I can't take 8 from 3. I've got the common denominator, which is awesome, but I can't do the subtraction, so I borrow. 51 is going to become 50. The one that I borrow, I'm going to add to 3/21, and I'm going to add it in as 21/21. So it's easy to make 1 out of any fraction or out of any denominator. You just put whatever you want your denominator to be. You put it in the numerator and denominator. You've got a value of 1, and it's got the common denominator. Let's clean up. So this is now going to be 50, and I want to add 3/21 to 21/21. So that's going to be 24/21. Don't worry about the improper nature of that fraction at the moment. It's going to work itself out in just a minute. All right. So now I've got 50 and 24/21 minus 25 and 8/21. So 24 minus 8, I can do that subtraction now. I get 16/21. And then 50 minus 25 is just 25. Okay. You want to always look to see if you can simplify. So factors of 16 would be 16, 8, 4, and 2. None of those factors will divide into 21. So 25 and 16/21 is your final answer. Okay. So hopefully that was a decent overview of how to subtract fractions and mixed numbers where you do have the same denominator. In the next 2 videos, we're going to talk about adding and subtracting again. But in the next 2 videos, we're going to have different denominators. So the process is going to be a little bit different. We're going to have to first find an equivalent version of each fraction where we do have a common denominator. So we have to find an LCD, or the least common denominator. We have to get equivalent forms of the fractions. Then we do the process that we just did in these last 2 videos, okay? So practice this video and the previous video, make sure you got it. And then if you can master these 2 videos, it's going to make the next 2 videos a little bit easier for you. All right, good luck.